Well, let me start out by saying, Ken, that first of all, I am not a religious person. I don't think any of us are. Yes, there are a lot of religious fanatics in flat Earth because,
I
the
didn't
Bible is
know.
kind of a flat Earth book, from cover to cover, because it doesn't describe a sphere or anything like that. But all that aside, every other cosmology that has been talked about by different civilizations shows the Earth to be this kind of flat with a dome over the top of it, right? And this goes way, way back in history, and all of these different cosmologies and civilizations have, kind of defined it that way. And so, and even our Bible, it talks about how it was created and how God created the firmament over the top, like, kind of like molten glass that he puts over the top. So I looked at that and I said, okay, so what if that's real? What kind of evidence is there for that? And what I found was amazing. There's there's a lot of optical phenomenon that will kind of demonstrate that. The fact that we are able to sit inside of a 14.7 or 760 torr atmosphere next to a 10 to the negative 17th vacuum without blowing the atmosphere off into space. And, they say, well, gravity takes care of that. It's like gravity's way too weak to take care of that. It stands to reason, at least in our minds, that we are in something that is in fact covered. Okay. So, and if that's true, there should be several things that are indicators of that. So the fact that we're pressurized, that's one thing. There's a lot of interesting things that go on up in, space that I find kind of interesting. For example, when the a lot of the observatories are looking at the stars, they have this little tool that they can create an artificial star. Are you familiar with this?
Yep.
To calibrate?
Yep.
Okay. So what they say they're doing is they're firing a laser up to about 62 miles or 100 kilometers, and it's hitting something they call a sodium layer. And with that, it fluoresces the sodium layer, and then they are able to then take that low magnitude or high brightness light and feed it back to the mirrors and actually modulate the mirrors on the telescope so that it removes a lot of the atmospheric distortion.
Correct. Yeah.
Okay, so
I've
my
seen
question,
those. I've seen those little capillary actions on the back of the reflector telescopes and where they attach that.
yeah,
Actually,
it's amazing. It is absolutely amazing. So, that's kind of interesting that they do that. And it just happens to happen right at 62 miles or 100 kilometers. So that's kind of our magic number, is what we're looking at here, at least in my mind, is the lower extremity of the firmament. Okay, so what else do we have that tells us that? Um, and we also have, well, if you've ever watched a NASA launch or anybody launch, when they launch off, they are going horizontal, usually within 30 seconds. And their typical explanation for that is, well, you have to get up to escape velocity, which is Mach 88, to be able to get outside of the Earth's atmosphere. But that, from what we can tell, we've never seen that happen, even when it's filmed from long distances away. They never go straight up, and they never appear to go all the way out into space.
They go
So
out to
that's,
the Bermuda Triangle and they crash into the ocean.
yeah, and we actually have footage of them recovering that.
Right.
Okay, so
And
another thing.
go ahead. Go
Oh,
ahead, Bob.
I was just saying another thing, another bit of evidence. Are you familiar with the phenomenon of sprites and elves?
yeah, I did a couple of videos on it.
Okay, cool. So then you understand that, it's very interesting that in order for there to be a discharge of an electrostatic discharge, obviously there has to be a pretty enormous difference of charge potential. Yes?
Yep.
Okay. So
I
when
used to
we
live on
look at,
Lightning Alley.
oh, did you really? I bet that was
Yeah.
interesting. In
Fun.
Florida?
Yeah.
Yeah. Okay. So when we look at this, they have really gotten some great footage on it recently. And every time that one of these upward discharges takes place, not only do they go out, but they flatten out. They hit something like they're flattening out at the top, right? And guess where that happens? 100 kilometers, 62 miles. Why would that happen? Well, I
Let me,
honestly,
go ahead, finish and I'll interject. Go
okay.
ahead.
Well, again, my idea is that this is part of our enclosed system, and I will get into that. with, you know, how basically the upper level is a Gaussian type of plate, and the Earth is kind of like a gigantic capacitor. And, you know, there's evidence for that as well. But go ahead, and David, what were you going to say?
I was going to say there was, you know, NASA always gives us these edited videos, but in Arizona they shot up the Go Fast rocket, amateur rocket, a bunch of years ago, and it went straight up with an unedited view. We're looking down, and there's a side camera too. But at right around 62 miles, it went kerplunk. It went into something thicker, not what maybe water, you know, some sort of plasmic field or something, and that was interesting. And then it floated a little weird. I have this a little sped up. But when it turned on its side, something very interesting happened. We saw the night sky, and all of a sudden we saw the moon right there, right? Well, the moon at the time of this was over Australia. So the moon's over here, we're over here, and we could see the moon, right? If the Earth was a basketball and that rocket was a quarter of a millimeter over the top of that basketball, the moon was underneath the basketball, and somehow we saw the moon, okay? Interesting. And again, 62 miles is where it hit. Bam.
July 14th, 2014.
Yeah.
Yeah. So, and I can go on and on and on. We have a series, a ton of government documents, and I mean a lot of them, and I can send them too if you want to see them, from the Army, from NASA, from the CIA, from the Air Force. And they are all studies talking about the firmament and the characteristics of the firmament. And it's like, and they
I've
also
seen a couple of those.
Yeah, it's crazy. It's like
from
what?
CIA.gov.
Mm-hmm. Well, from all different branches, and also, you know, they talk about whenever they talk about in models for like aerodynamics of airplanes or the physics of how flight works, they always specify that everything is done under the assumption of a non-rotating and flat Earth. And they say this over and over and over and over again. It's like, well, what good are doing these types of tests in an environment that is completely foreign to that concept, right? It doesn't make sense. So, all right, so we have those, and, you know, there's just a ton of evidence. Ken, I'm not going to go through all of it with you, but ultimately, what we have come up with, or what I came up with primarily, and this is largely from your work, is that what's happening is that the Earth itself is an enclosed system. The firmament, the lower level of the firmament, is a large Gaussian type of surface, okay? Now, which basically is just a gigantic capacitor. The Earth acting as the negative ground and the firmament acting as positive. Okay, now how do we know that? Well, one of the things that mainstream science fully acknowledges is that there is an equipotential lines of force that go up at the rate of 100 volts per meter, and it can be measured. And of course, I knew that a long time ago. It never occurred to me. I'm also a ham radio operator, by the way. And, you know, I've been up on a tower several times. You come across ground when you're up a couple of 100 feet on a tower, and it'll knock your dick in the dirt, right?
Yeah.
So, yeah, and, you know, worked on top of buildings. But yes, that voltage is absolutely, positively, measurably there. It's acknowledged by the mainstream. Richard Feynman even writes in his books that they have measured it all the way up to 50 kilometers, which would give it a potential at 100 volts per meter of 5 million volts. And if it goes all the way to where I think it goes, to the firmament at 100 kilometers, well, that's 10 million volts as a baseline. All right. So, and this is where we get into the gravity. And actually, I have a video here that I'd love to play just a couple minutes of, David, when you get a second.
Which video? Which video?
It's Zach's video.
With the balloons. With the balloons.
Yeah.
Here, I got it right here. So we got these balloons hooked up to this wire that's hooked up to a Van de Graaff generator. We just got like a metal button on here. And so we have it at equilibrium. And now we're going to charge it up, giving it a positive charge. And as we add the positive charge, it goes down. Right. And as soon as we take, go ahead.
I was going to say, what we need to do is I need to lay the groundwork of this really quick.
Yeah.
Just so we could see. And Ken, I think you may have seen this because Zach said that he thought you actually commented on it.
Yeah, electrostatic
So
charge. I mean, so-called gravity does not exist. I've said that a million times, a million different
I
videos.
agree.
What you're showing in those balloons where it's actually falling towards the earth because of where you charge is no different than pulling your hand out of a box of styrofoam beads and you're trying to shake the beads off of your hand, still stuck to your hand. So
Look at Earth's electrostatic field. This is important because we, along with all the matter in this known realm, are inside of an electrostatic field. The Earth itself has a measurable negative charge compared to the air above it all across the plane. As soon as you leave the surface, there is a positive charge in the air around you that grows in electrostatic potential the further you go up towards the sky. It is a steady, gradual rise in potential, which tells us, according to the laws of electricity, that we are between two Gaussian surfaces. A Gaussian surface is simply a surface that encloses or distributes a charge. If there were only one surface, the rate at which the positive potential grew would be different. Knowing that we are between two Gaussian surfaces, we can also know that certain phenomenon will take place in all matter within the electric field, or area between the two surfaces. For this topic, we will first look at polarization through electrostatic induction.
Now, first of all, Ken, I have to tell you that we don't necessarily believe in the model of the atom at all, but since most people can relate to this as far as how you come up with charged particles, that's why we use this as an example. So I know you don't agree with that part.
that's okay.
But okay, but it gives you the idea. So
For sake of analogies, that's fine.
Exactly.
Electrostatic induction is a phenomenon where the positive and negative static charges on matter are slightly separated or polarized due to the electrostatic charge of its surrounding area. If one set of the object's surroundings is positive and the other negative, the negative charge on the object will be attracted to the positive area around it, while the positive charge on the object will be attracted to the negative area on the opposite side. So here on Earth, the positive charge on our bodies is always attracted down towards the Earth, and the negative will be attracted to the air above. This phenomena creates a slight force in that downward vector, because as soon as we leave the ground, we start becoming positively charged by the air around us and are now forced towards the negative of the ground. This is electrostatic acceleration. One might think that the attraction from above and below would cancel out completely, but it is the electrostatic gradient that creates a flow from the positive above to the negative below. Think of the Earth as a flat strainer, and there is a constant flow of water from above, moving very slowly, always applying a force in a downward direction. This would be considered a vector. The electrostatic potential difference getting stronger as you rise from the Earth will keep a steady pressure from above at all times until it reaches the Gaussian surface above. When we reverse the polarity of the electric field and put a negative surface above a positive one, we can reverse this electrostatic phenomenon and get things to stick to the upper plate as if it were the ground. This works with all types of matter. You can move wood, iron filings, and even human hair with these forces.
So basically, Ken, what we're saying is that it is, since we believe that we're in this container and basically we live on the dielectric inertial plane of the Earth. That's the circular part, the pizza part, right, if you will. And we have these Gaussian plates above us and below us, the Earth itself acting as a Gaussian plate. And I don't know if you know this or not, but the deepest hole that's ever been dug, the coal mines or something like that, is something like 8 miles down, and they cannot go any further down than that. they run into a very interesting substance down there that is virtually impenetrable. So that's what we're
that's in Russia, the deepest hole. I forget the name of the hole though. But
The Bora superhole or something like that.
the only thing they needed to change in that video is to talk of a negative charge. There's no such thing as a negative charge. Walter Russell said the same thing. We're talking about a ground or a discharge point. So, but that's just splitting hairs, though, of course. But
here's the hole, if anybody cares.
Since the drilling was stopped in 1992 and the project site was abandoned around a decade later, the Kola Super Deep Borehole has maintained the record for the deepest artificial point on Earth. Humans have since dug longer boreholes, including the 12,289-meter borehole drilled in the Al Shaheen oil field in Qatar, and the 12,345-meter offshore oil well near a Russian island. But the hole in Kola remains the deepest.
Indulge in a fantasy.
The stars, our only hope. Human action resounds in the heavens. The bell echoes above. What we decide here today will polish or crack the firmament. What shall it be? Human action resounds in the heavens. The bell echoes above. What we decide here today will polish or crack the firmament. What shall it be?